In the second video for this lesson on addition of mixed numbers, we're actually going to do a little bit of review of converting between mixed numbers and improper fractions. This will become a very important skill in the next couple of videos. So let's have a close look now at mixed numbers and improper fractions. How do we convert between the two? How do we go from a mixed number to an improper fraction, or from an improper fraction back to a mixed number? This idea you would have dealt with in previous years. Let's have a look at 2 1/3. So if I want to represent 2 1/3, I can draw two wholes and 1/3 of another. I could take those two wholes and I could split those into thirds. And then what I see is that I have 7 of those equal sections shaded. The whole has been divided into thirds, so we know that 2 1/3 is the same thing as 7 thirds. Just want to point out here too that I could look at it like this. So for the first whole, that's like a 3 out of 3. The second whole, well, that's a 3 out of 3. And this whole is a 1 out of 3. And if I was to add up all of these, if I combine them all, I get 3 plus 3 plus 1, which is 7 out of 3. If we consider the improper fraction, 8/5, and I know it's improper because my numerator is greater than my denominator, then I can convert that to a mixed number. I know that I got to get at least one whole out of this. And when we've represented with a visual, we would look at the denominator, and that would tell us to divide our whole into 5 equal sections, and then we would shade 8 of those particular sections. If I use a fraction rectangle and I divide it into fifths, then right now in that first whole I've shaded 5. So I got 5 out of 5 shaded. That's not enough. I got to bump it up to 8. So I draw the second whole and shade 3 of them. So 8/5 is the same thing as 5/5 and 3/5. I know that 5/5, well, that's one whole, and then I have 3/5 of another. So 8/5 is the same thing as 1 3/5. So there we go. We've converted between mixed numbers and improper fractions. But before we move on, though, I want to show you this. If I have 2 1/3, and I want to convert that into an improper fraction, here's a little process you can go through. I start with my denominator, which is 3. I multiply it by the whole number part, which is 2. And 3 times 2 is 6. And then I can add on the numerator. So 3 times 2 is 6. 6 plus 1 is 7. And then I put it over my denominator. So 2 1/3, as we already discovered, is 7 thirds. Let's just watch what happens with the 1 3/5. Start with the denominator, multiply by the whole number part, add on the numerator part. So I got a 5 times 1 is 5, 5 plus 3 is 8, and put it over your denominator. 1 3/5, same thing as 8/5. So some examples here. Let's figure out the improper fraction for each mixed number. We'll look at this probably a couple of different ways. So 2 2/5. I want the improper fraction. Let's look at it this way first. So 2 wholes. Well, if I think about the visual, if my denominator is 5, then 5/5 will give me 1 whole. Another 5/5 will give me a second whole. So that takes care of the 2 whole number parts. And then I'm left with another 2/5. If I add it up, a 5 plus a 5 plus a 2 is going to give me a 12. So 2 2/5, same thing as 12/5. And that is simplest form. If I used a little trick, if you want to call it a trick, 5 times 2 is 10. Add on the 2, and we get 12. Over the denominator, 12/5. In B, let's look at it both ways again. So for the 1 whole, well, I'm going to rewrite the 1 whole as 6 out of 6. I look at my denominator to see how I'm going to rewrite the 1. And then I have another 5 6 left over. Copy down that common denominator. Add the numerators. So 1 and 5 6. Same thing as 11 over 6. Little trick. 6 times 1. Add on the 5. 6 times 1 is 6. 6 plus 5 is 11. Put it over your denominator. A couple more examples. 4 and 2/8. This time we're just going to use the little trick to figure out the answer here. So I start with my denominator, which is 8. I multiply it by the whole number part. So I get 8 times 4. And then I got to add on the numerator. 8 times 4 is 32. 32 add 2 is 34. Stick it over your denominator, which is 8. So we get 34 over 8. This is an improper fraction. It is not in simplest form yet, though. 2 will go into both numerator and denominator nicely. Cut 34 in half, you get 17. Cut 8 in half, and you get 4. So 4 and 2/8 is the same thing as 17 over 4. Want to point out for this one, though, that if you're keen, you may notice that the proper fraction piece of this mixed number to begin with is not simplest form. So you could, if you wanted to, you could reduce that first. So 2 over 8, if you reduce 2 over 8, you will get 4 1/4. And then 4 times 4 is 16. 16 plus 1 is 17. And now you get your 17 over 4. So whatever you see, whatever you decide to do first, that's up to you. Just make sure final answer is in simplest form. In D, so we got a 12 times 3. Add on the 7. Okay, so 12 times 3 is 36. 36 and 7 is 43. All over your denominator is 12. And believe it or not, that is simplest form. In the second set of examples, we're going to figure out the mixed number given the improper fraction. In A, 8 over 7. I'm going to look at my denominator here, which is a 7. So then I know that, well, 7/7 will give me a whole. So I can get 7/7, and how many am I left with? Well, I'm going to be left with 1/7. So for the 7 over 7 piece, that's my 1 whole, and then the remaining proper fraction, 1/7. So 8 over 7 is the same thing as 1 and 1/7. In B, I look at my denominator, it's a 6. So what will make up a whole there? Well, a 6 out of 6 will make up a whole. So I got 15 pieces that I can play around with. So 6 out of 6, well, I can get another 6 out of 6, and that'll bump me up to 12 out of 6. And that means I have another 3 6 left over. So the 2 6 out of 6s, that gives me 2 wholes, and I have a 3 6, which I can reduce. 3 6 we know is a half. So what it all means, 15 over 6 is the same thing as 2 1/2. Let's have a second look at this particular example. If you notice at the beginning that 15 over 6, you may say to yourself, well, that can reduce, sure. I could divide numerator and denominator by 3, the GCF, and that would give me 5 and 2. So what that does, it makes the numbers that you're working with smaller. But then you approach it the same way. So if I have 5 over 2, then a 2 out of 2 will give me a whole. And then I can get another 2 out of 2, because that'll give me 2 plus 2 is 4, and I have one more piece left over. So for the 2 out of 2 parts, that gives me 2 wholes, and the remaining 1/2. Same answer as what we had previously, just a different way of looking at it. Either way, fine as con. In C, our numerator is 13, and our denominator is 2. What I'd like for us to think about here is how many full groups of 2 can you get out of 13? Well, if you think about it, you can get 6 full groups of 2, because 6 times 2 is 12. And 12 is 1 away from 13, so what I'm left with then is a half. So 13 over 2 is the same thing as 6 1/2. Similarly, how many full groups of 12 can you get out of 23? Well, one group of 12 is 12. 2 groups of 12 would be 24. That's too much. So I can only get 1 full group of 12 out of 23, and I'll be left with 11 more. So 23 over 12 is 1 11/12, which is simplest form. And I'd like you to now proceed to the next video.